There will be some problems that you're asked to convert logs to exponential notation or exponential notation into logs, and I'll show you how to do this. First of all, if I'm asked to convert from a log to an exponential, there's a trick that I use to do this. First, you start with your base of your log. So here I would start with 5. And then I make a little circle. The 3 that I get to first would end up being my exponent. And then I'm going to continue my circle to get to the 125. My 125 would be my result. So this logarithmic function as an exponential function would be base 5 to the third power equals 125. And we see this is a true statement. 5 to the third, 5 times 5 is 25, times 5 more is 125. The important thing is to start with your base, go across the equal sign to the other number. That will be your exponent on your exponential, and then the 125, that's the argument of the log, would be the result. Going the other way, from an exponential to a log, I think backwards. So I know that I'm going to make this into a log. Whatever the base of the exponential is will be the same as the base of my log. So I know it's going to be log base 2. Then I think backwards from the one I have over here and think, okay, whatever's on the right side of my equal sign would be the exponent on my exponential. So we see on the exponential you have exponent of 4, so we know in a log that 4 is going to be on the other side of the equal. The result is 16. The result will always be the argument of my log, and I can double check myself by making the circle that I did before. Base 2 to the fourth power equals 16, and so I know that this is correct. Okay, so converting, this would be the new exponential equation instead of a log equation, and this would be my new log equation instead of the exponential. Okay, first of all, on these kind of problems, be careful to see what they're asking for. So on this one, they're saying convert to logarithms. So for this particular problem, I believe that is actually 8 to the 1/3. I'm sorry you can't see it very well on here. That's 8 to the 1/3. So if we're going to convert this to a log, this will be log base 8, because the base will be the same as the base of the exponential. The 1/3 is the power on my exponential, so that will be on the other side of the equal sign. And then the 2 is the argument of my log. I can see by checking this that it would be correct. 8 to the 1/3 power gives me 2, so I know that's correct. The next one over, this would be log. The base of this exponential is e, so the base here would be e as well. The exponent on my exponential is negative t, so the negative t is on the other side of the equal sign. And then my result is 4,000. The 4,000 would be the argument of my log. Now, on this example, we don't write log base e. Log base e is the same thing as what we call a natural log, or ln. So you're going to see it as ln of 4,000 equals negative t. Okay, so this is one of our special logs that has a special base, so we'll write it ln. Next one over, we have 10 to the negative x equals 0.0001. So this will be log base 10, because that's the base of my exponential, equals the exponent on the exponential is negative x, and then my result would be the argument of my log, 0.0001. Now on here, I also don't write a base if it's log base 10. So this would be just log 0.0001 equals negative x. So if you have an log function and its understood base is 10, you actually don't write that. Sometimes what I also like to do is I actually like to use a parenthesis around my argument. That way we can see that that's what we're taking the log of. Up above, I think I got my 0.0001 a little small, so it kind of almost looks like an exponent. It's not, it's the argument of the log. And so sometimes putting an extra set of parentheses in can clarify that. Okay, coming down, these, we've been asked to convert them to an exponential equation. To convert these, I start with the base of the log, I raise it to the value that's on the other side, and then my result would be my argument. So 7 to the y power would equal 4x. The next one, we don't have a base on the next problem written. However, it's ln. We know that the base of an ln is e. So on this one, we'd do e raised to the 4t would result in 30. And that would be my new exponential equation. Okay, the last one, we have log of m is negative x. This one we also don't see a base written because it's log with no base. It would be understood to be 10. So we would do 10 to the negative x power equals m. And that would be our new exponential equation. Something very important to note is that every single log can be rewritten as an exponential equation. Every exponential equation can be rewritten as a log.